Well, I accidentally ended that video. Sorry. So this is for question 1, part C and D of the HSA science test. So we already went through and did part A and B. So now we're going to take a look at part C. So it says select the 2 conditions that are required for the ammeter needle to jump. We can use process of elimination for this. So if you scroll up to the pancakes and hit strike through, the coil must be 20 centimeters long. We didn't change the coil length at all. In fact, we did it with 10 centimeters. So this is not true. The bar magnet must be moving. That could be true. In fact, if we went back up here, if you remember, we actually, or even up to this last one, when we didn't move the bar magnet at all, we got a maximum current of 0. So I'm going to leave that one in. The coil material must attract magnets. Okay, well, let's see. We know, if we go back up to this first experiment, that all of the metals worked, but the plastic did not work. So let's look and see. The coil material must attract magnets. I remember that in the reading passage, it had a table that talked about attracting magnets. So if we look at our materials up here, so the experiment on the right-hand side, aluminum does not attract magnets, but it produced the strongest current. So that means that this is not true. It does not need to attract magnets in order to actually work. So I'm going to go back up and do my strike through. The coil material must conduct electricity. So again, we can use the same table. It's grayed out because I'm in strike through mode. But if we go back up here, the only one that did not produce any current was plastic. And plastic does not conduct electricity. So that could very well be one of our answers. So I'm not going to strike it through for now. And then the magnet must not touch the ammeter. We don't know. We never tried touching the bar magnet to the ammeter, so I'm going to cross that one out. The bar magnet's end pole must point in the direction of the motion. We don't know if that's true or not because we didn't actually test it out. So therefore, I'm going to cross that one out as well because I don't know if that's true or not. So we do have 2 answers that we did like. So I'm going to stop the strike through option, and then I'm going to select the last 2 that we have left. So yes, the bar magnet has to move, as you can see in this animation. It also shows us here in our data. So when we didn't move the bar magnet, we did not get a current. So that is true. And then the coil material must conduct electricity. So we just answered that one as well. It has to conduct electricity. Plastic does not, and therefore plastic gave us 0 current over here. So those are our 2 answers. The last one is part D. So click on each blank box and select phrases to complete the sentence describing what causes the ammeter needle to jump. So there's 2 pull down options here. So it says the ammeter needle jumps because a blank. So moving electric field, moving magnetic field, stationary electric field, or stationary magnetic field. These are all some big words. But if you recall from the animation, and if you recall from our experiment, we know that the magnet has to be moving. So stationary is like a stationary bicycle at the gym. You can pedal as much as you want, but it doesn't move anywhere. So stationary means it stays in one place. Moving means it moves. So we're going to go with moving magnetic field because we moved the magnet. And then the ammeter needle jumps because a moving magnetic field does what? It could induce a magnetic field in the coil. It could cause the coil to conduct electricity. It could induce an electric current in the coil, or it could attract or repel the needle depending on the direction of the poles. So it would be great if we could use strike through for this, but we cannot. So maybe it induces a magnetic field in the coil. Maybe it causes the coil to conduct electricity. Maybe it induces an electric current in the coil. So we're not really sure, so we're just going to take a guess. And I'm just going to walk you through this as if you were doing the test and you weren't sure. Then you would just choose one of these 3. The only thing that we know is it doesn't attract or repel the needle. So we're just going to select an answer. And then you just want to double check and think for a second. So does it induce a magnetic field in the coil? We just answered a question that says the coil material must attract magnets. So we know that it's not magnetic. So we're going to actually strike out this one. It does not induce a magnetic field in the coil. Could it cause the coil to conduct electricity? If we take a look at this table, we know that aluminum worked really well, and it is not magnetic at all. So it's not going to be this first one. Does it cause the coil to conduct electricity? All three of the ones that did induce a current, they all do conduct electricity. So it either causes the coil to conduct electricity or it induces an electric current in the coil. We could choose either one of these at this point. So we're just going to go ahead and select one of them. Induces an electric current in the coil. So the difference between this is one causes it to happen and the other one says induces, which is like it doesn't necessarily cause it, but it ends up making the coil do that. So what is conducting electricity? Meaning like it creates electricity. And then the other one is it induces an electric current. These two are very similar, like I said, but this one says electric current. And we know that it does conduct electricity, but we also know up here that the ammeter indicates that there is a current flowing through it. So we're going to choose the one that says electric current in the coil. So those are going to be our answers, and then we're going to go ahead and click on the pancake and score the item. We earned 6 points out of a possible 6, which is great. So we can see that we got green check marks for all of them. And you can also go through and let's say that we had chosen a different answer. So let's say that we weren't sure about that one and we had chosen causes it to conduct electricity instead. If you scroll up to the pancakes and score your item, you would have seen that we got 5 out of 6. So we did get partial credit for that. Most of the things we got correct, but the last one we did not. So this is how you want to think through these experimental questions.